Yeah, hello students. Today we are going to discuss about no. Uh, we will continuing our discussion in the module 2, and for today we will discuss about vector scan stereolithography machine, or you can say SL machine. Okay, so yes. Okay, so in stereolithography or the vector type vector scan SL machine, we create the solid part by selectively solidifying a liquid polymer resin using a UV layer. Okay, so this we are already knowing that in the case of stereolithography, we are having a wet, and in the vector scan stereolithography machine, this liquid is the photopolymer resin. Okay, so in the case of vector scan SL machine, what we are doing, we are solidifying selectively this liquid resin layer by layer in order to get your final product. Okay, or the printing of your desired component. The physical part are manufactured by fabricating cross-sectional contours, slice one on top of another. So it means that we are having this the slice data, and we are controlling the this movement of your UV laser layer by layer, so that the part is being part is being getting part is getting solidified layer by layer, and one layer is getting printed over another layer. Okay, so how this layer by layer printing is taking place? For this, the part being built rest on a platform. It means the part which it is resting on this particular platform, and which is dipped into the vat of resin. After each slice is created, the platform is lowered. Okay, so as soon as you suppose you have solidified the liquid resin corresponding to your layer 1, then what you need to do, you need to lower down this platform by certain uh, by the distance that is equal to your layer height. Okay, or by the depth which is equal to your layer height. Suppose in this case it may be delta z, maybe some millimeter, say 0.05 millimeter. Suppose it is your layer height. Okay, so in for after the creation of every your layer, or you can say solidification of that particular layer, you need to lower your platform, and uh, and the same process is repeated, that the laser start to trace the next slice of your CAD model, or your slice data, and build the corresponding layer depending upon the uh, geometry data. Okay, so this way the product is created from bottom up, from bottom to up. Okay, so generally it is written as bottom up approach. The creation of parts require a number of key steps like input data, part preparation, layer preparation, and finally laser scanning of uh, two-dimensional cross-sectional slide. Okay, so in in the input data, what we are doing, we are having the input data from your STL file, or your CAD file. Okay, so input data consists of a STL created from the CAD file, or reverse engineering data. What does it mean, reverse engineering data? There are two ways of creating your CAD model. Like in first case, we are visualizing, we are getting the or we are rather than we are collecting all the information related to your product, and we are creating a CAD model in a modeling software. And there are other ways that we are having a product, and suppose we want to replicate it, we want to create another product having the same shape and size. Okay, So in that case, what we are doing, we might have a scanner, like a 3D scanner, and if you move this scanner around your product, you will get the data corresponding, geometry data corresponding to your physical model. So in this case, what we are doing, we are creating the CAD model from the physical model by using a 3D scanner, or a device which is creating the model of your physical model into your computer model or CAD file. So this process is called collection of data. It is called reverse engineering data. Okay, it means we, instead of creating model directly in your CAD software, we are creating model from the 3D scan data uh, of your physical model. Okay, so this is this is about your input data. It may be directly a STL file, or which may be created from a CAD file, or you might be interested. So yes, so then uh, yes, input data. Okay, so we were talking about the input data. We are either we are creating CAD model, or as a your input data, or from CAD model you are creating your STL file, or you are collecting data by using the reverse engineering method. Maybe you may use a 3D scanner to, in order to get your data corresponding to your CAD model. Okay, so this way we are preparing the input data. Then the second part is your part preparation. Part preparation, it means that you need to specify some you know detail related to a part preparation, like you may require some support structure, you may require you know some specific you know data, or maybe you might be providing some you know uh, like in the case of part preparation, you might be providing some a steel file corresponding to your support structure. Okay, so in the case of part preparation, what we are doing, part preparation is a phase at which the operator specifies support structure to hold each cross section in place uh, yes while part is being part is supposed to be built, and provide it also provide the values corresponding to your machine language, or machine parameter. Okay, then the next stage is your layer preparation. Okay, so there may be because we are slicing your CAD model into into a small layer of, or you can say some small thickness of layers. Okay, or you can say into a series of slices. So there may be something which is some data which is related to your layer preparation. Okay, so like for in this case, when you are supposed to print your first layer, what will be the primary requirement? There must be some sufficient resin available on your platform. Okay, and as soon as you solidified your first layer, you will require further liquid resin above this your solidified layer. So for that, what you are doing, you are lowering your build platform by the thickness which is equal to your layer height. Okay, so this way this is there are details which needs to be taken care of related to your layer preparation. Okay, so let me read it. Layer preparation is the phase in which the STL model is divided into a series of slices, as defined by the part preparation phase and translated by software algorithm into machine languages. Then it comes to the finally laser scanning of two-dimensional cross-sectional slices. Okay, so the laser scanning of the part is the phase that actually solidifies each layer in SL in your SL machine. Okay, or in your stereolithography machine. Okay, so in the fourth stage, what we are doing, your laser UV laser is scanning your slices of 2D cross section, because obviously the cross section of your this sliced uh, part is 2D. Okay, you can visualize, you can see the features in 2D of your CAD model. Okay, in your each slice. Okay, so for corresponding to that, you need to plan your path of your UV laser, and you have to move your laser across the 2D cross section of your slice data. Okay, so after the building of the part using your vector scan SL machine, the part must be clean, post cured and finished. There may be requirement related, post processing requirement related to your product. Okay, these may vary depending upon the geometry, geometric features which are created or which are printed in your SL machine. Okay, then yes, then next comes to the SL machine, the machines which are responsible for this particular process, that is vector scan stereolithography. So in this we will see what are the different components of these SL machine, or rather than we can say what are the different subsystems of this SL machine. Okay, so as we can see here, the main component of this SL machine are, first one is your recoating system, then platform system, that is a mechanism which will be lowering your build platform. Then the wet, obviously the liquid resin which is filled in this particular rectangular block. Then we have laser and optics control system. Okay, laser and optics control system. Then laser and optics system. Then fifth one is your control system. Okay, so you will see these part. What are these? What are the function of these subsystem? Okay, let's say for recoating system. What is recoating system? Okay, so recoating is that to ensure that your liquid resin is available above your previously printed or previously solidified layer. Okay, so for that case, what we are doing, we are having a mechanism in order to lower the build platform as soon as the layer is solidified. Then we are having a rotator plate which moves over this solidified layer in order to maintain, or you can say maintain the uniformity of liquid resin above this solidified layer, so that when your laser is moving above this solidified layer, the liquid resin is getting solidified uniformly above this particular solidified layer. Okay, then build platform, you are already now I guess you are available. Then wet system. Okay, and rest we will be discussing in the coming slides. Okay, these are the subsystems of your SL machines. Like major sub component of your SL machine are your recoating system, which is having your recoating blade, then resin delivery system. Then talking about platform system, it is having your elevator and rise system. Talking about wet system, it is having your wet and resin level adjustment. Okay, so is for adjustment of your liquid resin depending upon the requirement of the part, or the layer which is supposed to be solidified. Then we have fourth subsystem, that is laser and optic system, in which we have beam generation, lenses, and scanning. And the last one is your control system, which is basically related to three subsystem, like environment related control, which is having temperature sensor. Then we have beam control, and which is also having your beam sensors in order to control your beam. Then there are system that is which controls your process. Okay, so these are the main subsystem, and we will be discussing one by one about these main subsystem of your SL machine. Like in the case of recording system, recording is done uh, recoating is done using a shallow dip or recorder blade sweeping. The process can be described as follows. After a layer has been cured, the platform dips down by a layer thin layer. So, this has been already discussed above. The recorder blade slides over the whole build, depositing a new layer of resin and smoothing the surface of the bed. Okay, so as I told in the previous slide, that when your first layer is solidified, okay, we have to ensure that the sufficient resin is available over this solidified layer in order to accurate, or you can say precise solidification of next layer. So for that, your quarter blade, what it is doing, it is moving over this whole uh, uh, solidified layer, and it is depositing a new layer of resin, and also smoothing the surface of your wet. Maybe there may be some surface, small surface irregularity. These are also smoothed using your recoating system. The common recoater blade type is your uh, Zephyr blade, which is hollow blade and that is filled with resin. The vacuum system pulls resin into the blade from the wet. As the blade translates over the wet to perform recoating, resin is deposited in region where the previous part cross section was built. When the blade encounters a region in which the weight without resin fall into this region, since its weight is stronger than the vacuum force. Okay, so this way it is smoothing the surface of your wet. Uh, One thing is very important in the case of your recording system, the blade alignment. Okay, so if your blade alignment is not proper, your blade may crash. Okay, and so in order to avoid your blade crashes, uh, because how it will crash, because it will crash when the blade hits the part being built and often delaminate the previous layer, because if it is striking with the previously solidified layer, obviously either blade is going to crash, or the printed part is going to be disturbed. Okay, so we need to be very sure about the blade alignment, otherwise we are not going to get the quality which we were supposed to get using your SL machine. Okay, yes. Then next comes the platform system. The next part is your platform system. The platform system consists of built platform that support the part being built. This has already been discussed, and an elevator that lowers and raises the platform. Okay, so normally when we are because we are when we are solidifying your the resin layer by layer, what we need to do, we need to lower the platform every time as soon as your layer, or the corresponding layer has been solidified. This elevator is driven by a lead screw. Then The next subsystem is your wet system. So in wet system, you can say the wet system is simply the wet that holds the resin combined with a level adjustment device and usually an uh, unautomated refill capability. Then the fourth system is your optics system. So optics system includes a laser focusing and adjustment optics uh, and two galvanometers that scan the laser beam across the surface of the bed. The modern SL machine have a solid state laser that have more stable characteristics than their predecessor. Okay, various gas lasers. Okay, so this is about your optic system. Then the last one is your control system. In control system, a process controls the sequence of machine operations. Uh, Typically, this involves executing the sequence of operation that are described in the build file that was prepared for a specific part or set of parts. Commands are set to the various subsystem to actuate the recoating blade, to adjust resin level, or changing the wet height, or to activate the beam controller. Sensors are used to detect resin height and to detect forces on the recoater blade to detect blade creases. Okay. The second, second objective of your control system is your beam controller. Okay, so the beam controller converts the or you can say beam control. The beam controller converts the operation descriptions into actions that adjust beam spot size, focus depth, and scan speed with some sensors providing feedback. And the third one is your environment related control or environment control, or you can say environment parameter. The environment controller adjusts resin weight, temperature, and depending upon the machine model, adjust environment temperature and humidity. So these were the basic subsystems of your SL machines. And now we will move to the SL resin curing process. How this your uh, your your resins are cured or solidified. What is the physics of this curing process when it is getting solidified by using your UV laser. Okay, so I've taken this one of the book. These parameters, well established, curing process. We will be discussing in coming few slides. The investigation into the fundamental interaction of laser energy with photopolymer resins. So there are some, nomenclature that has been discussed in order to represent the formulas related to your SL curing, SL resin curing process. Like CD is cure depth, then we have dP is your depth of penetration of laser into a resin until a reduction in irradiation of 1 by E is reached. Capital E is your exposure possibilities as function of spatial coordinates. EC critical exposure, and that is exposure at which resin solidification start to occur. Emax peak exposure of laser shining on the resin surface, or you can say center of laser spot. Okay, so yes, so these are some standard formulas. I will not be elaborating about these formulas much. Okay, so the irradiation at any point xy between x and x equal to 0 to x equal to p is given by suppose on this plane it is given by h equal to h xy equal to 2p, this particular formula, okay, related to in order to find the irradiation at any point xy between x equal to 0 and x equal to p. The fundamental general exposure equation is it is given by this uh, uh, that is the irradiation and exposure in the case of your, so exposure is given by this particular formula. Okay, uh, maybe I will take a few numerical problem that how to use these formulas in our calculating the irradiation and exposure. We will take a few examples in coming lectures. Okay. The cross sectional, then it comes to the laser region interaction. Suppose this was your cure depth, CD. Okay, so the cross sectional shape of a curved line becomes a parabola. Normally it is parabola, and it is given by CD equal to dp natural log of E max over EC. Okay, all these parameter has been defined here. CD cure depth, dp depth of penetration, AC critical exposure, Emax peak exposure of your laser. Okay, so this is how your Q depth is calculated. Then photo speed is typically used as an intuitive approximation of your SL photosensitivity, uh, and it is given by Vs equal to uh, Vs equal to your this particular expression is square root of 2 upon pi PL upon. Okay, so I have not discussed these formulas because we will be directly taking some problem related to application of these formulas. Okay, then it comes to the time scales. uh, so on the short end of the time scale, the time is it time it takes for photon of laser light to traverse a photopolymer laser is about a picosecond, that is 10 raised to the power minus 12 second. Photon absorbed by the photoinitiator or and the generation of the free radical or cations occurs at about the same frame. A measure of photopolymer reaction speed is kinetic reaction rate Tk, which are typically several microseconds. The time it takes for the laser to scan past a particular point on the resin surface is related to the size of your laser beam. The time is called the characteristic exposure TE. Values of TE are typically 50 to 2000 microsecond. Then it comes to the to your scan pattern, SL scan pattern when we are moving ahead. And here we can see yes, just a second. Yeah, leave it. Okay. So if you want to elaborate more, I have taken more details about this radiation and exposure. I will be skipping these. Okay, you can go through it. I will be sharing these PPTs, radiation and exposure. Okay, so for today, I will stop here.